All right, here is a second example for identifying the key attributes of an absolute value function. And so here we go. We're going to jump right into it. We have the function is equal to -2 times the absolute value of x plus 3 plus 6. All right, and you can see it's graphed here using Desmos.com. And let's jump right into it. So the domain of this function is -infinity to +infinity. And all absolute value functions in this form are going to have that domain. And you can see it on the graph. We have a continuous V shape, and our V is going to continue to go to the left. It's going to continue to go to the right. And so there's no real starting or ending point for the x values. Therefore, the domain is -infinity to infinity. The range, of course, is different. The range is either going to have a maximum value or a minimum value depending on the graph. And so we can see in the equation, a is negative, which means that we're going to be opening downwards, and you can see in the graph that we are in fact opening downwards, which tells us that our vertex is at the top of the graph, which means that the maximum y value is 6. And so let's see, when I write that range then, since 6 is the maximum, I have to put it on the right side, and I'm going to give it a square bracket because it's part of the vertex, and so it's definitely part of the graph. And then in that case, what would the lowest value be? Well, we have these arrows at the bottom saying that it's continuing forever, which of course means it's heading toward -infinity. So the range is from -infinity with a parenthesis to 6 with a bracket. And so that means that the y values of this function, all of the outputs, so no matter what input you put for x, the output will always be between -infinity and 6. So meaning it's going to actually be less than or equal to 6. You could write actually that y is less than or equal to 6. That would be another way of writing this using inequalities. Let's stick with interval notation though, but be sure to understand that they are actually the same. Okay, the vertex then, we can see it right there on the graph. I've already circled it. The vertex is at -3, 6. And is the vertex the maximum or minimum of the function? Well, in this case, it's at the top of the function because we're reflected down because of our -2. So it is a maximum this time. And what is the axis of symmetry? Well, remember, the axis of symmetry would be that invisible line that cuts the graph perfectly in half, and we're looking for the x value because it's a vertical line, and so that's at -3. So x equals -3 is our axis of symmetry. And then we just have to answer the x-intercepts and y-intercepts. And so over here on the left we have an x-intercept, and right here we have an x-intercept because that's where they're crossing the x-axis. So our x-intercepts are at -6, 0, and 0, 0. And then our y-intercept, if we're looking to see where it crosses the y-axis, we actually see that in this graph it's the same as one of our x-intercepts. And so the y-intercept is also 0, 0. And that's all there is to it, guys. When you are finding the attributes of an absolute value function, all right, if you're given a graph, you can find everything by looking at the graph. If sometime you're not given a graph, there are ways of doing it, like you can look at the left and left, right, up and down transformations to know that, hey, we're going to go left 3, so that would be -3 for C. We're going to go up 6, so that means that D is 6. And so our vertex would be -3, 6 according to the equation. And notice how C equals -3 also ends up being our axis of symmetry. All right, and there are just multiple ways of doing finding the key attributes even if you don't have a graph. All right, there it is. That's it for this example.